Hello, Lisa. It's Kingsley Thompson, and today, being Tuesday, I did the first pre-recorded video, and the time here is 5:20 something p.m. So I hope you actually understand and get to enjoy the video. So we're talking on first degree equation and inequalities in one variables. So what I actually did today was that I drafted out some stuffs out for you, some stuffs out like this stuff and more for you to see. So, because I can't write at the same time on video, because actually I have someone to help me. I could have been doing that, but nobody to help me out. So I'm doing it all myself. So first of all, we're talking about first degree equation and inequality in one variable. So I left out inequality in one variable out because it's not essentially important right now. Not that important right now. Because we can't do everything in one day. We have to go step by step. So first of all, the question you ask yourself, is there any other name for first degree equation? What is a first degree equation itself? So a first degree equation is also known as a linear equation. They have quadratic equation, they have polynomial equation, they have different equation, they have simultaneous equation, they have fourth degree equation. So we start with first. The linear equation is just the same as if it was a first degree equation. A quadratic equation is a second degree equation, and like that they have polynomial equations like that and all. So now after that, what else ask yourself is, the next question I asked was, what is an equation? You must know what an equation is before you start solving an equation. You can't just jump into conclusion and start solving what you don't know. So an equation is a mathematical equality characterized by having an unknown element called the initial. So that is what an equation is. And I give instance of what an equation is. This is an equation: 2x plus 1 equals to 5. This is an equation. And equal signs, please, if you see how I wrote it, this equal sign plays a very essential role in equation, because it all deals with equality. So it plays a very essential part in the equation. So I also wrote this stuff down here to show you that this is not an equation and this is not an equation, because there's no equal to sign attached to them. So the next was, what is the degree of an equation? The degree of an equation is actually known by the exponent the x value is carrying. That is what the degree of an equation is. You can know the degree of an equation by the x exponent. If the x exponent is 2, you know it's 2. You know this is a second degree equation. You know this is a third degree equation. I know this is a fourth degree equation. I know this is a infinity equation. Well, once the degree of the equation is when x is equals to 1, so you know that if it's raised to power 1, then you know that the equation is actually a first degree equation. But for this one, it's a second degree equation, this is a third degree equation, this is a fourth degree equation. But once x is raised to power 1, or s has no exponent at the top at all. You know, when x is on its own without any exponent, it is known as raised to power 1, and that's what they call a first degree equation. So next, now looking at this equation here, you know this is a third degree equation, because the highest value of x exponent is 3. You know this is a third degree equation. So that is just what you need to know about degrees of equations. So now, what's a first degree equation? Now, a first degree equation are those equations where x is only elevated to 1. I showed an example here where x is elevated to 1. Or in other words, x appears simply as a grade 1, like x is on its own. There's no exponent at the top. And I actually showed you I told you from the start, from here, what degrees of equations are. So coming down here, this is the form of a first degree equation. This is the form: ax plus b equals to 0. is a form of any first degree equation, and this is for second degree equation, but also for a first degree equation. So anyway, you see ax plus b, you know this is a first degree equation. So now when equations are not simplified, you only see them in parentheses, you see them in brackets, and you see them in denominators and fractions. That's when they are not yet simplified. When we go further, you understand what all this thing means. So this is what I was talking about when equations are not simplified. Are not yet simplified. This is an equation. You can see the equal to sign here. This is a fraction. This is in a bracket. This is a fraction. This is a bracket. This is a denominator. This is a parenthesis. This is a denominator. This is a parenthesis. This is a denominator. This is a fraction, and so on like that. They are all in fraction. You must see the equal to sign to make you know that these are all equations. They say all these equations must be previously simplified in order to solve them. You must actually simplify all these equations here to get the value of what? Your x. These ones are yet to be simplified. These are just some examples of first degree equations you must know. So now, how can we solve first degree equation? There are different ways to solve first degree equations, like different ways of solving first degree equation. So how can we solve first degree equation? So now we go to solve first degree equation. It is commonly said that you have to clear x. But what does it mean to clear x? That's a very, very simple. That's very, very easy. What does it mean to clear x? Now, to clear x, we have to go through a series of steps to reduce or simplify the equation. What that means that when we're clearing x, is finding x on its own, making x stay in one place, and the numbers in the other side of the equation. And to do that, equation like this now, we must simplify it to the lowest term, to the extent there's only x that's remaining, and a number at the other side. That's the way we can actually clear x. And there are other practical rules for solving first degree equation. There are actually practical rules for solving first degree equations. So, and number one of our rules, when a term is adding to a member, I see when I mean member, this is a member. This part of this equation is a member, the first member, and this part of the equation is the second member. This part of the equation is the first member. This part is the first member, and this part after the odd equals to is called the second member. That's what this present will tell us here. When a term is adding to a member, it passes through the other member restando. What it means that, what that stuff actually means that when this term is adding, this term will cross over. Collecting like terms will cross over to meet his own alike person in this member. And that's just simply what it means. Same applies to multiplication and division. When you're multiplying, the other member divides through everything. As I'm multiplying, if you see what I wrote it here, when the term is multiplying in one member, it passes to the other member, dividing the entire member. The same thing with division. When division is passing from one member to another, it's multiplicating everything all through the entire member. So now there are steps for solving first degree equation. These are just practical rules. These are the rules for solving first degree equation, and these are the steps to solve first degree equation. First, you reallocate the terms. Second, another name for reallocation of terms is collecting like terms. Looking at the whole equation now and looking for the ones that actually look alike and collect them. Then secondly, you simplify group. You simplify. That means when you simplify, after collecting the like terms, if you need to divide, you divide. If you need to multiply, multiply. If you need to add, you add. And the last one, you clear x. So I'll actually show you an example on this or what it means to reallocate, simplify, and clear X.